Alright, Trig students, we're going to move on today to double angle and half angle formulas. If you recall from last time, we worked on angle addition and subtraction. Well, it's always angle addition, but it's when we were adding angles or we were subtracting angles, particularly the ones that we found on the unit circle, in order to come up with new angles, and then we could find the exact value of those trig functions. So we're going to do the same thing, only instead of adding or subtracting different angles, we're going to either double them or take half of them, and we'll develop some formulas here to show you that. So we're going to use these double angle formulas when you're going to want to find the, let's turn that blue. When you're going to want to find the sine or the cosine of an angle that is twice or double, twice as big as an angle that you know the exact trig value for. So people get these confused, these double angles and half angles. The easiest way to think about it is when I look over here, okay, these double angle formulas, I am looking for the trig function of an angle that is twice as big as something you know, or something that appears on the unit circle. Okay, so let's look here. For instance, just very simply, if this were 660 degrees, if I wanted to know the sine of 660, well, I know that 660 is 2 times 330. Okay? So 330 would be that angle that I know the trig functions of, because it appears on my unit circle. Okay? Now I'll show you where both of these are derived from. And they're derived from the angle addition formula. Okay? Sine of 2 alpha, it would be the same as sine of alpha plus alpha, right? Because alpha plus alpha is 2 alpha. Well, this is sine addition. Fits right into sine addition formula. We just happen to be adding the same thing, right? So as you see, this would fall into sine alpha cosine alpha plus cosine alpha sine alpha. These are the same thing, right? They're commutative. They could be written the opposite direction or opposite way. So I've got two of them. So the double angle formula for sine is 2 times the sine of alpha times the cosine of alpha. Okay. Now cosine can work two different ways. Okay, cosine of twice an angle, again, it's the same as taking the cosine of alpha plus alpha, right? So what that falls into, we will have cosine times the cosine, right? Cosine alpha times cosine alpha. And remember, we switch the sign for cosine addition. And then it would be sine alpha sine alpha. Well, that is cosine squared alpha minus sine squared alpha. Now don't be tempted to say that this is equal to 1, remember it's cosine squared plus sine squared is equal to 1. Okay, and now we'll actually develop two different formulas from this. Okay, the first we'll show in green here. So what we want to do is we will make we'll turn cosine squared into sine squared because we want them to be in terms of one trig function here, or we can make them in terms of one trig function. So if we did that, cosine, I want to turn everything into sine. Cosine squared is equal to 1 minus sine squared. We know that from the Pythagorean identity. And then minus sine squared. Well, when I go ahead and combine like terms, this is 1 minus, I've got 2 sine squared alphas. Okay. The other one, if we wanted to turn things into cosine squared, cosine squared alpha minus, and then sine squared is 1 minus cosine squared alpha. If we simplify, we'd have cosine squared alpha minus 1. So we're going to have a negative 1. Cosine squared alpha minus a negative cosine squared alpha is going to give you positive 2 cosine squared alphas, and subtract that 1. So I've got double angle formulas are for sine are 2 times the sine and cosine. For cosine it would be 1 minus 2 sine squared or 2 cosine squared minus 1. Okay, so you've got one formula for double angle for sine, you've got 2 for double angle of cosine here. Actually 3, because you've got this original one, right? So we'll write those down here, these double angle formulas. We've got 2 sine alpha cosine alpha, or the cosine double angle can be cosine squared alpha minus sine squared alpha, or 1 minus sine squared alpha, or finally, and that was 2, I'm sorry, 1 minus 2 sine squared alpha, or 2 cosine squared alpha minus 1. Okay. Okay, we'll move along to the half angle formulas, and then we'll get to some examples. Half angle formulas. We're obviously going to use this if we want to find the sine or cosine of an angle that is half the size of an angle that you know the exact trig function of. For example, if I wanted to know the sine of 67.5 degrees, well, 67.5 is half of 135, so that's the same thing as having that right there, right? Okay, so these are equal, right? Because 135 divided by 2 is equal to this. These are equivalent numbers. We've just rewritten them because I know the exact value of 135 from the unit circle. Okay, I'm not going to develop these formulas. If we have time, I may show you that another day. because it is kind of interesting how everything develops mathematically. But let's go ahead. I'll give you these. The sine of half angle, or the half angle formula for the sine, is plus or minus. And it is a plus or minus because you have to take the square root of 1 minus cosine theta over 2. And the half angle formula for cosine is also plus or minus because we take a square root of 1 plus cosine theta over 2. Okay. So what we will be able to decide here, though, is whether or not it is actually positive or negative. Okay? Because the quadrant in which alpha over 2, or the angle we're trying to find, so up here it would have been like 67.5. We have to figure out where that is located, the quadrant it's located in, and that will tell me whether it's going to be positive or negative. For instance, the sine up here, 67.5 is in quadrant 1, and we know that sine is positive. So if I plugged into this equation here, I would know I would get the positive value. Okay? It's key that we understand we're looking for where the 67.5 is and not the 135. Okay? We've got to make sure that we understand that we're talking about finding the sine of this value, but we're using this right here in our equation. Okay? That's why, remember, this top number is our theta. Well, we're using theta in here because this would have been 135, right? Well, we know the exact values of that. Okay. So again, it's pretty much like it comes down to identifying patterns. So let's do the easy stuff first. Simplify to a trig function of a single angle. So what you need to do here is recognize the pattern, and 1 minus 2 sine squared of 20 degrees. Well, what that looks like to me is the double angle formula for cosine, right? If you might want to look back at your formulas here just to double check. That is in fact the cosine of twice whatever alpha is here, and we should notice in the pattern that alpha is 20, right? So this is the cosine of 2 times 20, which we know is the cosine of 40 degrees. Okay. Now over here, we're looking at the square root of 1 minus cosine of 110 degrees divided by 2. I should notice right away that I have a square root, so I'm talking about a half angle formula. I'm subtracting, so that means I am talking about if we go back to this last one, if I'm subtracting in there, it's the sine half angle formula, right? So this is equal to the sine half angle, which is the sine of my theta is 110, right? 110 over 2. Put those in parentheses, so this is, as I write it, to a single angle is sine of 55 degrees. Okay. So, as we have said before, this is about recognizing the patterns, right? So, let's go ahead and plug these into patterns and see what we can get. So, we want to find the sine of 3 pi over 8. I should recognize right away that 3 pi over 8 isn't on the unit circle. Therefore, I'm going to try to figure out what this is. Is this 2 times some angle that's on the unit circle, or is it half of what's on the unit circle? So 3 pi over 8, if it helps out, you can change this to degrees. That doesn't bother me at all if you change 3 pi over 8 to degrees. Myself, I can recognize that 3 pi over 8 is half of 3 pi over 4. Just like 1/8 is half of 1/4, right? So a fraction is always half of whatever it would be if you cut the denominator in half. 1/4 is half of 1/2. Okay, so I know that this is a half angle, half of 3 pi over 4. So that's going to be my theta. Now, while I'm going here, I should also, since I know I'm going to have positive or negative, I should try to establish, well, since the angle I'm looking for, 3 pi over 8, if it's half of 3/4 pi, then that means it is going to be in quadrant 1, because 3/4 pi is in quadrant 2, right? So half of it would be is in quadrant 1. Then we know it is going to be positive. So I go down here, sine, oops, come on pen, the sine of 3 pi over 8, I should recognize, is equivalent to the sine of 3 pi over 4 divided by 2. And then we can recognize that 3 pi over 4 is in fact my theta. So when I plug into the formula, okay, remember my formula is 1 minus, is its sine half angle, 1 minus the cosine of theta over 2. Well, when I start plugging in, that is 1 minus the cosine of 3 pi over 4 over 2. So this is 1 minus. Now, what people tend to do is they leave that cosine in there, but I'm looking for the cosine of 3 pi over 4. So I go look for the x value. Is it cosine or the x values on your unit circle of 3 pi over 4, and I recognize that that is negative root 2 over 2. Okay? And all that is over 2. So as I'm simplifying, I'll just head down here. Okay, 1 plus root 2 over 2. Because when I subtract a negative, I get a positive. And now it's rules of radicals and simplification from here. You can follow along here. You can try this on your own, or you can just follow along and get the feel for what we have here. So the first thing we're going to need to do is combine these terms in my numerator. So I'll have 1 plus root 2 over 2. Well, to get a common denominator, I'm going to have to make this 2 over 2 plus root 2 over 2, right? The 1 becomes 2 over 2. So that is simply 2 plus root 2 over 2, and all that's over 2. So when I'm dividing fractions, remember that I multiply by the reciprocal. So as I come down here, this is going to be the square root of, I've got 2 plus root 2 over 2. That's the numerator. And then to multiply by the denominator, or the reciprocal of the denominator, I'm going to multiply by 1/2, right? That's the same thing as dividing by 2, multiplying by 1/2. So I end up with 2 plus root 2, and I've still got the square root, right? 2 plus root 2 over 4. Okay. Now, this will be an acceptable answer. I'm going to simplify even further to show you what the book might show. The book recognizes it as this right here. If I have that is the same thing as having 1/4 times 2 plus root 2 over 1. Okay, so I kind of just took that 4 out front. It's 1/4. Well, the square root of 1/4 is 1/2, right? And now I would just be left with the square root of 2 plus root 2. So again, this right here, acceptable, or the book might possibly simplify down even further if you're checking your answers. So you can see identifying things up here is the easy part. Identifying which one it needs to go into. Going ahead and with the math is oftentimes the more difficult portion of this. So let's go ahead and continue with this. The cosine of 105, I should recognize that that is also a half angle. So it is half, it's not twice something that I know, right? It's twice 52.5. Well, I don't know anything about 52.5. So I should look for half, and that is half of 210 degrees. And then since 105 is in quadrant 2, then cosine 105 is negative, right? So I know I'm going to have the negative value. Okay, so cosine of 105 is equal to cosine of half of 210. Alright. So if we start plugging this in, we're always going to have that negative out in front of our root. It's going to be 1. Now for cosine, remember it's plus the cosine of theta. So that'll be 210 over 2. So I'll work a little quicker through this time. 1 plus, and the cosine of 210 is negative root 2 over 2. All that's over 2. And you should start to get the pattern here, negative. Now I've got to combine my numerator. This would be 2 over 2, right? So it would end up being 2 minus root 2 over 2 when I got a common denominator. And all that's over 2. Next step, remember, multiply by the reciprocal, so I've got 2 minus root 2 over 2 times 1/2, which gives me 2 minus root 2 over 4, which could also be, if you want to simplify even further, I could take out a 1/2 from this, right? 1/2 square root of 2 minus root 2. And make a note if you want further clarification of this step right here, and I will clear that up at the beginning of the next class. Just make a little note so you remember to ask that question. Okay? We're going to keep plugging along here. These notes are rather lengthy, so I want to keep going here, reach about the 30-minute mark, and then we'll probably finish up the remainder of the video in class. So let's look at a problem here. It says if cosine is -4/5 and theta is between 0 and 180, I want you to find the sine of the double angle, the cosine of the half angle. Well, in order to know this, we need to know the sine. They give us the cosine, we need to know the sine. So we're going to start by figuring out what the sine is. Well, if I know it's in quadrant 2, or it's between, I know that it's between quadrants 1 and 2, right? It tells me it's between there. So if it's negative and it's cosine, then it can't be quadrant 1, it must be quadrant 2. So I'll just draw it in here, rough sketch. Well, cosine is, if you remember, is your x value over your r value. So as I draw a reference triangle, x value, that's my -4. If that's 5, then we should be able to recognize right away that our y value is going to be 3. Therefore, my sine of this angle, theta, because this was theta right here, right, is 3/5. Okay? Now, that's one way to find it. The other way to find it would be to use the Pythagorean identity. Okay? So you could have also looked at this Pythagorean identity where sine squared plus cosine squared is equal to 1. And if I filled in the blanks here, cosine is -4/5, so cosine squared, alright, so sine squared plus -4/5 squared equals 1, so sine squared plus -4/5 would be 16 over 25, right? 16 over 25. If I want to solve for sine, I'd subtract 16/25 and get 9/25. So then I'm just taking the square root of both sides to get what sine is equal to. So now sine would be equal to plus or minus 3, whoops, sorry. It wouldn't be square root, right? It'd be plus or minus 3/5 because I took the square root of that. Or no, let's just leave that in there for now. And what I want to identify now is this going to be positive or negative? Okay, so I kind of skipped a step that I didn't want to. So let's leave that as 9/25. Is it going to be positive or negative? Well, I know we're talking about sine, and I know it's in quadrants 1 or 2. Well, sine in both of those is positive, right? So the sine of theta is equal to the positive square root of 9/25. Square root of 9 is 3. Square root of 25 is 5. And I could have gotten it that way too. Okay, so either way you're comfortable with. If you're a picture drawer over here, if you're an algebra person, you might prefer this way. Okay. So what I'd like for you to do now is, if you're watching this video, you can go ahead and you can stop for now, and then we will watch the remainder of this video in class. It won't be too long, but I didn't want to take you much past a half hour. Okay, so we'll pick it up right here when you come back in. Alright, so you guys are probably in class now. Sine of the double angle, because this asked me to find sine of twice theta and cosine of half of theta. So we're simply plugging into these values now. So since we've got 2 theta, here's our pattern, right? Okay, in order to find the double angle, I need to know the single angles, and that's what I found up here. So just plugging values in. 2 times the sine of theta I found to be 3/5, and the cosine of theta was given to me was -4/5, and when I go and multiply that all out, I know the sine of the double angle is -24/25. Okay. Now, the half angle formula of cosine goes like this: plus or minus square root of 1 plus cosine theta over 2. First thing we should do, if we can, is identify whether it is going to be the positive or the negative. And down here is where I'm going to figure that out. Okay? So since they gave us that theta was between 0 and 180, then what I'm going to look at is, I want to know where theta over 2 is. So just divide that by 2, and that gives me that. But if I divide that by 2, remember, you have to do that to every part of the inequality. Remember, we did this in like the first or second day of trig. I told you, don't forget it. Okay, so that's theta over 2. So if theta is between 0 and 180, that means that theta over 2 must be between 0 and 90, which tells me that the cosine, that's in quadrant 1, right? Therefore, that cosine will be positive. Okay? So I'm going to be dealing with the positive value of this here. Now let's go ahead and tackle it. So I'm going to have 1 plus the cosine of theta, which was -4/5, and that's over 2. So combine my numerator. You can mentally get a common denominator, or you can just plug it into your calculator. 1 minus 4/5, okay, you should realize is 1/5. That's over 2. So when I simplify that, I've got 1/5 times 1/2, which is square root of 1 over 10. I want to go ahead and simplify further here, so that I know is square root of 1 over square root of 10, which is 1 over root 10. Okay, we never want to leave a radical in the denominator, so if I were down here and I had this, then I've got to multiply by root 10 over root 10, and that will give me a final answer of root 10 over 10, and we know that's positive, right? Okay. So the easy part of this is probably identifying what formula to put it into. Unfortunately, what you're probably going to find to be the most difficult is the simplification of this. So you need to have a handle on your rules of fractions and radicals, and at this point in trigonometry we shouldn't be having difficulty with that. Alright, to wrap up today, we're going to prove these two identities here. So we'll just get right into it. I would look at this one and recognize that the left side of this is in fact the more difficult side. Now obviously use some common sense too. We're dealing with double angle and half angle formulas, so probably what you're going to be looking at is using those to prove these identities. You notice right here I've got one of my double angle formulas in both the top and the bottom. So if we use the sine double angle, that is, I want to switch back to blue here, that would be 2 sine of alpha cosine of alpha, and I've got 1 minus now the cosine double angle. Remember, there are 3 different variations of that, but I think what I want to use is the one that has the cosine and sine in it. So let's take a look at that one first. Well, I wouldn't have to. Let's see here. Because if I did that, yeah. Instead of that, let's get 1 minus. So if I look back at my original formulas, I just had an idea. I could get the one that will allow me to get rid of the 1. So if I'm subtracting, if I have a positive 1 in these parentheses, then that's going to allow me to get rid of the 1. And the double angle formula for cosine that has a positive 1 is 1 minus 2 sine squared alpha. Minus 2 sine squared alpha. Yeah. Right? Yeah. Okay. So now I'm going to simplify. So I'm going to have 2 sine alpha cosine alpha over 1 minus 1 is going to go away, right? So I'm going to subtract 1, it's going to go away. I'm going to subtract a negative 2 sine. It's going to give me a positive 2 sine squared alpha. And what this is going to allow me to do is simplify out the 2's, simplify out this sine and one of those sines. I end up with cosine alpha over sine alpha, which we know is equal to cotangent of alpha, and we're done. Okay, so I could have plugged in either one of these double angle formulas and eventually gotten there. I think this is probably the one that made it the easiest, but you didn't have to recognize any further patterns, but it really wouldn't matter. You would eventually be able to get there as long as you took the correct steps. Okay, our last one, cosine theta times cosecant theta minus sine secant. So what I'm going to do here is probably turn things into sine and cosine when I can. Okay, so Remember, when you've got addition or subtraction separating terms, that's typically going to be your most difficult portion. So I'm not going to try to do anything to this side. I'm going to work with this side. For one, we haven't gone over tangent, cotangent, double angle formulas. So let's go ahead and tackle this. Cosine times cosecant is cosine times 1 over sine, right? So this is the same as cosine theta over sine theta, because cosecant is 1 over sine. This one likewise would be the same as having sine theta over cosine theta. Same thing. Alright, so what I would have here then is I could change these to sine and cosine, or tangent and cotangent, right? But then that's not really getting me anywhere, because I have to get that double angle in there somehow. Okay? So here's the process that I would take. I recognize that if I change it to cotangent, tangent, it's not going to get me there right away. So another option would be able to find a like denominator. Okay? So if I want to find a like denominator, it's going to be sine cosine, right? So I multiply the two denominators, which means I need to take this times, if I want to get cosine in the denominator here, I've got to take cosine over cosine. Over here, I'm going to have to take it times sine over sine. That'll give me the denominators I want, and I'll end up with cosine squared minus sine squared. Okay? So I can notice right here in the top, remember this is not a plus, so it's not equal to 1. It is subtraction, which I should identify as being, let's switch colors again, that is equal to the cosine, now my pen is sinking, cosine of a double angle, so twice theta. And that's over sine theta cosine theta. Okay. And now, I know I'm going to need to introduce a 2 as a coefficient here. So here's another thing I can do. Remember, you can multiply anything by something equivalent to 1. So there is no problem with me simply multiplying by 2 over 2. Because I haven't changed the value, I've just changed the components of that. Okay, so now I've got 2 cosine 2 theta over 2 sine cosine theta. 2 sine cosine. I recognize that 2 times sine cosine is equal to, so I've got the same thing. Let's switch again. 2 cosine 2 theta. I recognize that this is the double angle formula for sine. 2 times sine cosine is the sine double angle formula. So if I've got cosine over sine of the same thing, that's equal to cotangent of the same thing. So I end up with 2 cotangent of out 2 alpha, and that's our proof. Okay. Your homework is going to be page, let's see, page 649 2 through 36 even. Okay, let me double check that. let's do that. Okay, so let's go with page 649, 2 through 36 even, and we'll go from there. Alright, remember we'll watch the last part of this video in class, unless you just want to finish it. That's perfectly fine. See you later.